We had a look on the gradient descent and that example which we plotted up in our last chapter. But now we will be focusing with the example like this is the data.csv, that is the comma separated two values which we have. And with this we are going to do a functionality with the gradient descent where we will be creating a function for step gradient, gradient descent runner, and various type of points running on it, and accordingly we will be printing the values and that will be available in our command prompt. So for that I'll just have created a folder over here, and this will have a file name gradient descent example where I will be importing values from numpy, that is the numeric py values, import star, and this will have the computation with the value as def compute error for line given points, and then comes the values such as b, m, points, and then taking up a value with respect to compute errors like total error equals 0 for I in range of 0, length of points, and this will be computed with a value of x equals points of I of 0, and then y equals points of I of 1. And then it comes the next value as the total error appends with a value that is y minus m into x plus b, and this will be taken like it will be taken in such a way raised to 2. Then it will be return total error divided by float with the value of length of points, length of the given points. So this is for the computing error for the given line. As if you remember in the last chapter, we have taken the gradient in one single line that was quite visible over there. So we will be focusing based on that aspect only over here. And the next thing is to create a step gradient. So function will be definition step gradient, and then getting a value that is b underscore current, then value over here as m underscore current, and then the points associated to it, and after that we have the learning rate. And after getting the associated learning rate, we will be calculating b underscore gradient equals 0, then m underscore gradient equals 0, and after that we will be taking next aspect as n equals float of some values, that is length of points associated to it, and then later comes for I in range of 0, length of the given points, then it will be taken as x equals points of I, 0, and then y will be taken as points of I, 1, and then we have a value that is b underscore gradient with a value as concatenated with a value that is 2 by n into y minus m of current with a value that is into x. Then this will be calculated. Now this particular thing will be calculated with b of current, that is b underscore current. So this part is done successfully. After this, the next scenario is to get the learning rate. So the learning rate is calculated with new b. So new of b, that is new underscore b, equals b of current minus learning rate into b of gradient. So this value needs to be calculated. Then after that we have new of m equals, this value will be calculated as equals m of current minus learning rate into m of gradient. So after this we will return the value as return new of b comma new of m. So these two values will be computed over here. Then we have the gradient descent runner. So gradient descent runner is nothing but the one with the points and the starting b calculations and starting m calculations with the running rate which needs to be computed. So that will be taken here as def gradient descent runner. Then we have the points, associated points with the starting b calculation, and then we have the starting m parameter, and after that we have the learning rate calculation and the number of iterations. So all of them will be taken over here. All of these values needs to be calculated over here. That will be taken as b equals starting b, and then we have m equals starting m, and after that we have for I in range of number of iterations with the value that is b comma m equals step gradient with the value of b comma m comma array of points, and then we have a learning underscore rate, and after this we have a return value that is return b of m. So once these things are being calculated, we'll get the run value. Then after that comes the definition for run. The run function is purely for running a particular function, so it is def run. The logic behind the run function I'll explain you in our next chapter.